Welcome to SP Smart's NEET Direct program. Today we shall discuss the solution of the assignment related to the thermodynamics part first. So let us start with question first. A Carnot engine whose low temperature reservoir is at 7 degrees C. Well, that means T2 is 7 degrees C. You change this into Kelvin, it becomes 280 Kelvin. And it has an efficiency of 50%, that is 1 by 2 is mentioned here. So I use the formula, this is half, it is 1, it is T2, which is 280 divided by T1, where T1 is the temperature of the heat reservoir. Okay, now you simplify it further. You rearrange the terms. It's 1 minus 1 by 2 is 280 by T1, and that means 1 by 2 is 280 by T1. T1 therefore is 560 Kelvin. Right, this is the case 1. Now the question says that you have to increase efficiency to 70 degree, keeping 7 degrees same, that is 280 is same, but percentage increase should be 70%. Right, so once again I write this, it is 70%. Right, so it is now, as you can see, 280. T1 is unknown, it is 7 by 10. So carry on, it is now 1 minus 7 by 10 is 280 by T1. It is 3 by 10 on this side, it is 280 by T1. Right, T1 therefore is 2800 by 3. Right, so it turns out to be 933 Kelvin. Therefore increase in temperature, that is initially we had this 560, right, I write here 560, and now it is 933 simplified for, and it comes out to be 373 Kelvin. That should be the answer. Now let's check out 373. Which option is it? 373 is nearly 380, because we have to give the nearest possible answer. So option D is the correct option for this problem. Okay, now let's move on to question second. Two Carnot engines A and B are operated in succession. I write here A, I write there B. Alright. A receives heat from a source. T1 is at 800 Kelvin, as written over there. And its sink is at T2, which is not known. Right, it's not known. Second engine B receives the heat rejected by the first engine. So T2 is T2 prime, that is this heat rejected goes to B, and this supposedly is its T1. The second engine B receives the heat rejected and rejects to another sink. It leaves it to next sink at 300 Kelvin. It's written over there. The work outputs of the two engines are equal. The work of one and work of two, they are equal. Then what is T2 value? This is what you're supposed to find out. Now let's analyze the whole situation. Efficiency of A, as you know, output by input. That's it. And for B, it is output by input. Right, this is for first, this is for second engine, as discussed here. Now as you know that Q1 by Q2 is T1 by T2. Right, now as per the conditions given in the problem, the efficiencies of the two are equal. That is, work done by A, work done by B, they are equal. This is possible only if T2 minus T3 by T1 minus T2, they are what? They are equal, right? And if they are equal, they cancel out. This is 1. So T2 minus T3 is T1 minus T2, is by cross multiplication. Now you bring T2 on this side, it becomes 2 T2 T1 plus T3, because now I'm bringing T3 to this side. Alright, you go further, it's T1 plus T3 by T2. Put the values. T1 as per the problem here is given to be 800 and T3 is 300. So this is 800, this is 300, right? And therefore, so this on simplification it is 1100 by 2, this is 550 Kelvin. So answer to this problem should be 550 Kelvin. Now let's check out which option is it. 550 Kelvin is option C. So C is the correct option for this problem. Now let's move on to next question, question third. For the given cyclic process CAB shown for a gas, the work done is, well, since this is a cyclic process, this is the closed curve, the area under the curve or enclosed by curve is equal to work done. Alright, so it is half base into altitude, because this is a standard formula for the area of the triangle. Now base is AC, altitude is AB. You simplify it further. As you can see, A to C, it means difference between these two. That is 5 minus 1 into AB. AB means difference between this and this. That is 6 minus 1 is 4 by 2 into 5. So it is 10 Joule. So 10 Joule is the answer to this problem. That means option B is the correct option for this problem, right? Okay, now let's move on to question fourth. A Carnot engine has an efficiency of 1 by 6. Eta is 1 by 6. And as you know, eta has a formula T2 by T1 1 minus. Okay. So instead of eta, you put the value 1 by 6, 1 minus T2 by T1. Alright. So T2 by T1 is 1 minus 1 by 6. That is 5 by 6. Ultimately, this means T2 is 5 by 6 times T1. You call it number 1. Now, in the second case, it's written the efficiency is doubled. So, efficiency double means twice of eta, 1 minus T2 by T1. But T2 has been further reduced by 62 degrees. So, 62 degrees. And remember, reducing by 62 degrees C or reducing by 62 Kelvin is one and the same thing. So, I've not used Kelvin, I use degrees C. It's alright, doesn't matter. As far as the differences are concerned, they are equal. Now 2 into eta, as per this, eta was 1 by 6, so it's 1 by 6, 1 minus T2 minus 62 by T1. Simplified further, 1 minus 1 by 3, T2 minus 62 by T1. It's 2 by 3, and here it is T2 minus 62 by T1. Cross multiply. 3T2 minus 186 and 2T1. Okay, now put this value instead of T2, right? 5 by 6 T1. So it is 5 by 6 T1. It is now 186 has been shifted there, plus 2T1. 5 by 2 T1 minus 2 T1 is 186. It is now T1 by 2 is 186. T1, therefore, make the cross multiplication. So it has to be 372 Kelvin. And this on simplification makes 99 degrees C. So this one of the options. Temperature T1 is 99 degrees C. Now put in expression first, where T2 you are supposed to find out. So T2 would be, just check out 5 by 6 T1. So it is 5 by 6 T1, right? So you bring the value T1 from here. It is 5 by 6 times 372, and you bring it further to the simplest number. It is 310 Kelvin, and on simplification further, we can find that its value in degrees C become 37 degrees C. So our answers are 99 degrees C and 37. 99 and 37, let's check out. 99 and 37, option D is there. First high temperature is 99, lower one is 37, right? Hence, I put here option B as the correct option for this problem, right? So in this way, we have finished the solutions of the assignment from the chapter of thermodynamics part first. First question has option D as the correct option. Second question has option C as the correct option. Question third has option C as the correct option. And question four has option D as the correct option. And that's all for today. God bless you all.